The integral test states that if the area under f of x from 1 to infinity is finite, and there is an f of x continuous function for the sequence an, then if the area is finite, they behave the same, so the series of an must converge. So here we have in 1a, we have 1 over 2n, just going to circle that, 1 over 2n minus 1. And we want to know if that converges. So what we're going to do is we're going to use the function 1 over 2x minus 1 and see what happens with that area. So we're going to say the limit, since this is an improper integral, and we're going to go from 1 to infinity of 1 over 2x minus 1. And then we're going to go ahead and integrate this expression and see what the area is. So the limit as a approaches infinity, and we're going to end up with log 2x minus 1. And because of that extra 2, we need to divide by 2, and our bounds are going to be from 1 to a. So we're going to substitute in those bounds. So we're going to have the limit as a approaches infinity of, I'm just going to take that 1/2 out of there. So we're going to have 1/2 log of 2 times a minus 1 minus log of 1. So it's going to be 2 times 1 minus 1, which is log 1, and that's going to be 0. So we're going to then evaluate this limit by plugging in infinity. So log of 2 times infinity minus 1 is log infinity. That's going to be infinity. So this area is infinite. Okay, so the statement I said was that if the area is finite, that an converges, but the converse is also true. That's not necessarily the case in math, but in this case, the converse is true. If it's infinite, it diverges. So the area is infinite. Okay, so that my conclusion is, therefore, the series from n equals 1 to infinity of 1 over 2n minus 1 diverges.